Now see a bulk modulus of elasticity. Suppose you have taken a spherical body like this, and this has got original volume, that is V, and you apply force from this side, all sides, that means you are giving here compressive stress. Its volume reduces to this one, so that will become V minus delta V. So there is a decrease in the volume by this delta V. Now you have to find out the bulk modulus. So bulk modulus, that is represented by here capital B. We can write B is equal to normal stress, that is actually compressive stress, upon volumetric strain. So this can be written here F upon A here minus delta V upon V. Negative sign I am using here because there is decrease in volume, and this can be written B is equal to minus PV upon delta V. So normal force per unit area is known as pressure. So that is P stands for pressure and V is original volume and delta V is decrease in volume. So this is the formula for bulk modulus, and if you take the reciprocal of this bulk modulus, that is called here K, can be written 1 upon B, and this is known as compressibility. So this is known as compressibility. So reciprocal of the bulk modulus is known as compressibility. Now see here, this is the question based on the bulk modulus. Determine the fractional change in volume of slab when subjected to a hydraulic pressure of 10 atmosphere. So now B is equal to given to you this, and 1 atmospheric pressure is equal to this much. You know it. B is equal to PV upon delta V here, change in volume. So we can write change in volume upon V, that is the fractional change in volume, is equal to, that is P upon B, and P is equal to 10 atmosphere. So that we can write 10 into 1.013 into 10 raised to power 5 Newton per meter square, that is Pascal, divided by, we have to write B here, that is 37 into 10 raised to power 9. So when you solve it, you will be getting 2.74 if you solve this part here, 10 raised to power minus 5. So this is here the fractional change in the volume. That is very simple question, just we have used the formula for bulk modulus.